Let's begin. I first want to talk to you about yesterday's assignment. Okay, so yesterday's assignment was an activity, okay, to learn about this particular law that we use in statistics, which we call the law of large numbers. So many people, when they draw the graph, and then they see the shape of the graph, right? Then terus dirang kencang lah, like, sir, we've never seen this kind of graph before. How do we know? Okay, the point of the graph is not to see whether the number of is correct or not. The point of the graph is to show you that when we do an experiment, when we do a certain research, okay, we find that the more number of trials we have, we find that the probability of getting the result that we want seems to gravitate, okay, atau seems dia macam cenderung mendekati kepada nilai mean secara teori. Theoretically, okay, think about this. Theoretically, when you flip a coin, we know that one time you flip the coin, you have a 50-50 chance, okay, 0.5 probability of getting a head or getting a tail, okay. But does that mean that you can only do it one time, terus terbukti sudah? What if the first time kamu flipkan, kamu dapat head? Does it really mean that you will always get a head the next time you do it? Or what if the first time kamu flipkan, terus kamu dapat tail? Does that mean that your coin does not follow the mean probability? Okay, it doesn't mean that lah. Just like all of you lah, the first time you set for your admits exam, okay, those of you who failed, does it mean that you're always going to fail? The same thing for those who pass lah. Does it mean that you're always going to pass, or does it mean that that is your level where you're at? Okay, it doesn't mean that. Okay, and we cannot make a suitable conclusion based on just one time. Okay, so bab kata pepatah kan, don't judge a book by its cover lah. Doesn't mean satu kali kamu buatkan itulah jawapannya, maka itulah jawapannya untuk selama-lamanya. Okay, and that's the whole idea behind this normal distribution. Okay, in this experiment, you only flip 30 times. What if you flip it 1,000 times? Okay, like in this case, you flip it 1,000 times, and then you try to see. We find that whether you do it 30 times or 1,000 times, the bigger the number of trials, lebih banyak kali yang kamu flip, makan, you will find that the probability akan lebih mendekati kamu punya theoretical mean. And that is actually the reason why I wanted you to do this activity yesterday. Okay, is to understand now why in binomial distribution kita punya bilangan trial bahkan usually is about 10, maximum maybe 12 lah. Okay, tetapi it cannot work for a situation where we need so many trials. Okay, kita perlu lebih banyak uji kaji. We need more experiments. We need a bigger sample size. Okay, so when the sample size is very big, okay, then we have to change the distribution. We cannot use binomial distribution. Okay, for example, if you have 1,000 times, right, don't tell me for a binomial graph, you're going to draw 1,000 lines. Draw until pengsan, Okay, so binomial distribution is suitable when your situation only has very few trials, very few times that you flip the coin, very few times that kamu melambung dadu, very few times yang kamu memilih satu bola daripada satu kotak. Okay, so maybe in that particular experiment, you only take the ball out 10 times. Then we use binomial distribution to show the value of the mean and the standard deviation. Okay, but if you have to put the ball back in and then take another ball for 1,000 times, you're going to count 1,000 probabilities. It's quite crazy lah. Okay, so that's where we use normal distribution. Okay, and the standard that most mathematicians use lah. Okay, the standard that most mathematicians use for how much is a lot. Okay, and this is kind of a standard, especially if you are interested in doing research in the future. Okay, we find that the standard is about 30. Sorry, I'm sharing another screen. Okay, minimum of 30. Sorry, can you see? Can you see the screen? Sorry.
Yes,
Can
yes, yes.
see? Okay. So for an experiment where your number of trials is minimum 30 lah. Okay. So more than or equals to 30. Usually we want to represent the mean and the standard deviation by using a normal distribution. Okay. Contohnya kamu melambung dadu sampai 300 kali. Okay. So we kind of want to use the normal distribution for that. Okay, but if your number of samples or number of trials that you do is less than 30, okay, we usually like to use binomial distribution lah. Even then 30 okay, 30 is a lot lah. You want to draw 30 lines, okay, it's a little bit a lot lah. Okay, and that is the reason why I wanted to do yesterday's activity, to show you that normal distribution is something that a lot of people use every day, because people deal with data, people deal with a lot of data every day. So it's good to represent the data, it's good to analyze the data and represent the data using a suitable distribution, which is called a normal distribution. Okay, where I told you yesterday, the normal distribution is a bell curve. The number in the middle is always the mean, okay? And the standard deviation will tell you whether it is high and thin or low and fat. Okay, whether it is not so spread out or very spread out. Okay, means ada banyak beza daripada ini dan ini. And in the normal distribution, the random variable okay, is normally distributed with two very important numbers, which is the mean and the variance. From the variance, you can count the standard deviation. Okay, but now the problem is this, what if your mean is always changing? Okay, what if your mean is always changing? Then it's very difficult to count the probability. It's very difficult to, because if you change the mean, you have to change the graph. Okay, example. Okay, and this is where I want to show you how to use Desmos. Astaga, banyaknya screen sharing. Sorry people. Today is just pay attention to me but ada juga sedikit dalam workbook Okay, so this is the Desmos graphing calculator. Okay, so this is the laptop version. You will find that in the app version is also the same. Okay, so if you have Desmos, this one, so what you do is, this is where you input the function lah. So if you want to show a normal distribution graph, so you write normal dist, okay, then you put the bracket, and as I said the first number is the mean, the second number is the standard deviation. So say for example your mean is 40 and your standard deviation is 2.3. No, standard deviation tapi dalam buku kita is variance lah kan, okay? So the normal distribution for 40 and 2.3, okay, will look something like this, except that we need to zoom out. Because you know where is 40? 40 is like all the way over there. Astaga. Can I change the scale on this? Hold on, let me change the scale. Oh, never mind lah. Saya kasih gerak lah. Okay. So mean is, this is so tiny, sorry. Okay, the mean is 40 and the standard deviation is 2.3. So you see that the probability, okay, sorry, the curve looks like this. Okay, mean is 40, titik yang paling tinggi adalah 40, and the standard deviation is 2.3. 2.3 is actually a very big standard deviation. If I change the standard deviation to a smaller one, let's say 0.23, so this is a very small standard deviation. Okay, look at how thin. Okay lah, sorry, this is very mengada-ngada lah. Let's do 1.2. Okay, other one. 0.89. Okay, something like this. Yeah, cantik juga. 0.5. Okay, 8 mau. 0.4. The one. 0.63. No, the one. 0.65. Sorry, 0.7. 0.8, 0.9. Alah, makin lama makin gemuk. Okay, di sana. 0.7. Okay, so when we use 0.7, once again the mean doesn't change. Okay, the mean is still at 40, but the standard deviation when you change the numbers, as I said before the bigger the standard deviation, the more spread out, the lower your distance will be, makin spread out. Tetapi perkara yang paling penting okay, the most important thing is that the cumulative probability maksudnya daripada infinity sampai ke infinity okay, the total probability which is represented under the graph is equals to 1. That's the most important thing. Okay? The most important feature about the normal distribution is that the area under the graph, okay, boleh dihitung. Today, I'm not going to teach you how to count it. I just want you to understand this concept. Under this graph, the red color, the whole area, even though over here is so tiny that I cannot see, right? Can I make the scale bigger? Oh, I can make the scale bigger. Bodoh. Okay, now, so you see, actually, let me make it bigger. Okay, do you see? It's actually not touching the graph, you know. Let me make it even bigger. You can't. It's actually not touching, you know. Okay, it actually haven't touched. Ada sedikit area di sana itu. Okay, there is a little bit of area there. So the whole area, okay, let me make it even bigger. You see now. Okay, it never touches the x-axis. Okay, that's why I said the entire area. Sorry, zooming out. Okay, so I want you to, once again, I remember everything down here, right? Actually got space one, you know, ada sedikit area di sana. Okay, so the entire area from negative infinity all the way to infinity, okay, equals to 1. So this is a very good app, or this is a very good device to help you to figure out how to count the probability lah. Okay, so this number will show you the probability. Let's say I want to find the probability of 40, okay, from the mean until infinity. Because the mean separates the graph into two parts, so the probability will be 0.5. Sebab jumlah luas daripada 40 sampai ke hujung, sampai ke jana is 0.5. Okay, what if I change this to infinity and then this one I put 40? Daripada 40 to negative infinity, sebelah kiri, also the same. It will be 0.5 probability. Okay, sebab daripada mean sampai ke hujung sebelah kiri, hujung ke janah lah. Okay, the probability is 0.5. So the key important thing, okay, and this is something that you need to remember when we go into class next week. The area under the normal distribution graph represents the probability. You just have to know, you want to find the probability from where to where. Okay, so for example, okay, let me choose this 38 until 42. So for today, okay, so you can put the minimum is for 38 and then the maximum is 42. Okay, like this. So from 38 over here, let me zoom this in so you see. Okay, so you see beyond 38 dia tidak kasih warna. Okay, and beyond 42 dia tidak kasih warna. So much to say that this graph, this whole part, okay, the area is 0.9957252606604. Maksudnya, kebarangkalian kamu mendapat nombor daripada 38 sampai 42 adalah 0.995725226604. That's what this means. Okay, dengan syarat the mean is 40 and the standard deviation is 0.7. If I change the standard deviation, for example, I change the standard deviation to 0.8 or no, 1.2, you find that the probability also changes. Okay, walaupun nombornya sama 38 sampai 42, the mean is still the same, but when I change the standard deviation, the area under the graph also changes. Maksudnya kebarangkalian kamu mendapat kebarangkalian kamu mendapat nombor antara 38 sampai 42 adalah 0.90441929544. Okay, fine lah, 0.904 lah. Okay, cukup 3 tempat perpuluhan. Okay, but this is how you play around with the normal distribution. Now, if you're very interested, you can also mengada-ngada, and you can also do binomial lah if you want lah. Binomial dist. Okay, and then remember the two important numbers is how many trials you have. 10 kali kamu mencabut melambung dadu and the melambung shilling, and the probability is 0.5. Okay, so this would be how you would get lah. So where is the mean? The mean is somewhere here. Okay, this is the graph. Okay, this is the binomial graph. Okay, for 10 trials, 0 sampai 10 sahaja. Okay, and then the mean is 0.5. The probability of success is 0.5. How much is the mean? The mean is 10 times 0.5, the mean is 5 lah. Okay, so this is how the binomial distribution graph will look like. Okay, this is what we've learned before. But today we're not interested in binomial, we're interested in normal. But the only problem with the normal distribution graph is, what if our mean selalu berubah-ubah? Let's say let's choose another number, 2 lah. Okay, 2 and then the standard deviation is 0.2. Oh, nama, so big. Okay. Astaga, 1.2. Okay. So let's say I have a distribution like this. Okay, my mean is 2 and then this one. Okay, and then suddenly I find that alamak, saya silap. Okay, I want to change to my mean menjadi 20. So I have to move my graph down all the way until 20 like that. So it becomes very mafan, because what if your mean is 2000? Okay, saya tidak jumpa sudah di sini. Okay, I have to zoom out until I find 2000, which is like, mana itu 2000? 2000. Oh dear. Okay, look at the 2000. Can you see the normal distribution is so sad and so tiny? Okay, punya lah jauh. Okay, so this is a problem when we do, especially when you're going to do research. Okay, because sometimes kan, contohnya lah, kamu buat survey bahkan, kau bukan selalu buat survey dengan 10 orang. Let's say you want to have a survey, okay, of people who don't like BTS. Okay, contohnya lah. Okay, so you do a survey. Okay, do a survey, then you go around the whole school, find all 1,800 people, and then people who don't like BTS. Okay, so you, yeah, okay, then you find the probability and everything. But the problem is, your number is very large, 1,800 students in SM Tokyo. You want to know what is the probability of people who don't like BTS. Okay, say for example. So because of that, we have to represent the big mean. Okay, contohnya dalam case ini bahkan mean ini besar, sangat besar. Okay, we have to represent the big mean, okay, and whatever standard deviation it is, okay, into a standard normal distribution. Let me repeat this. You can open your textbooks. You can open your textbooks to page 170. Okay, because different people will use different mean depending on their own experiment. If your mean is 2000, then this will be your graph. But if your mean is only 300, then your graph will be very much different. Okay, so because of that, okay, we have to convert whatever data we have into a standard normal distribution. Okay, now the standard normal distribution, let me show you. Okay, oh no, I have to go back to, sorry, hold on. I have to go back to 0. I'm sure there is a way to go back to origin, tapi saya tidak. Okay, origin. Okay, so normal distribution of 0 and 1. Astaga, 0 and 1. Yeah, okay. Normal distribution. Okay, for a standard normal distribution is a distribution where you have converted the mean to become 0 and the standard deviation to become 1. Saya ulang balik, different experiments will give you different mean and different standard deviation. So in order to make things easier, some brilliant mathematician, what he did was, he said, okay, let's use a formula so that we all need to use the same graph. We don't have to draw 100 million graphs to show the distribution. We use the same standard graph, okay, where the standard normal distribution is 0 mean and 1 standard deviation. 0 means your highest point is at 0, and your standard deviation is 1, means, okay, this one I will explain later, 1. Okay, so this is the first thing that I want you to learn. This is the next thing that I want you to learn today. Okay, take a look at this graph very carefully. I'm going to stop sharing and I'm going to go back to my whatever like the thing is. So how do you convert? Okay, how do you convert whatever mean and whatever standard deviation you have into the standard normal distribution? Okay, so how to convert, okay, any mean, okay, to standard normal distribution. Okay, so this is how we do it now. Let's say I have a random variable that is normally distributed. The mean is 40 and oh no, cannot. I cannot simply use another number. Okay, the mean is 23. Okay, and the standard deviation is 5. Oh, sorry, variance pula kan. The variance is 25. Okay, so mean is 23. My variance is 25. So what is my standard deviation? Oh, come on.
5.
Okay, my standard deviation is 5. So how do I convert this? Okay, macam mana saya convert, okay, untuk supaya dia keluar X and then my mean will be 0 and my standard deviation will be 1 or my variance is 1. Okay, this is how you convert. Okay, you change your mean, okay, the conversion is called Z lah. Okay, the conversion is called Z. Okay, and then we use mean. Sorry. Sorry. Okay, X minus mean over standard deviation. This is a very important formula. Okay, we call this the Z score. Okay, Z equals to the X. What the X ini akan diberi. Okay, is given. For now lah. Okay, for now it is given. X is given. Okay, and then your mean is mu. Okay, or this one, and then your standard deviation is the one seperti yang di sini. Okay, so sebagai contoh let me give you an example. Let's say after I plot my graph I find that I have a bell curve and then my mean. Okay, my mean is not 0, but my mean is 23. No. My mean is 23. Okay, fine. My mean is 23. Okay, but I want to know what is my Z score for this number. Let's say this is 30. Okay, so what is the Z score for 30? Okay, I'm going to use the same example. The mean is 23, the standard deviation is 5. So we calculate the Z score. Z equals to 30. 30 is the number that you want in the graph. Okay, minus the mean, which is 23 over 5. What is my answer? Sorry?
1.4.
1.4. Okay, now what this simply means is that I have now converted this number 30 to become 1.4 if I now draw a standard normal distribution. Standard normal distribution is the bell curve, highest point is 0. My mean now is 0. Okay, and so this 30 over here, which I calculated over here, this is 1.4. The green color and the purple color are exactly the same thing. Cuma the purple color has been standardized. Okay, dia sudah kena kasih standard supaya memudahkan pengiraan. It makes a lot of calculations, which I will teach you next week, become much easier. So this is the first thing that you need to learn for yourself this weekend. Okay, is how to convert any X score into Z score. And the formula is very simple. Okay, the X score minus the mean divided by the standard deviation. Okay, please open your workbooks open your workbooks to page 69. Okay, open your workbooks to page 69. I'm going to give you 5 minutes, 10 minutes. 10 minutes. No, you know what? I only want you to do one question. No, 2 questions. Please do number 1 and number 4. Okay, do number 1, number 4. Find the Z score for the random variable X. Okay, remember to use standard deviation. Don't use variance. Okay? Okay, 5 minutes. Number 1 and number 4, question B, page 69. Okay, let's just go ahead. Now, the first thing that I want you to notice is that number 1, the answer is 1.5. Okay, but number 2, your answer is -1. So the question is, bolehkah kita negative answer? Okay, is it possible to have a negative answer? Okay, so let's take a look at this. Let's take a look at the number 4 question. Okay, number 4 question dia cakap, under normal circumstances, under ordinary circumstances, dalam keadaan biasa, the taburan normal is the mean 34 and the variance is 2.5. Okay, can I have the standard deviation for this, please? Somebody?
2.5.
Bodoh. 2.5. The variance is 2.5 squared. Okay, fine. So the standard deviation is 2.5. What but this question? Okay, so let's draw it in the normal graph. Normal graph means, normal graph means my highest point, okay, is the mean. So this is 34. Okay, now the question is asking now, my x is 31.5. Where is 31.5 in this graph? It is somewhere on the left hand side, kan? It is somewhere on the left hand side over here, 31.5. Since my x is less than the mean, obviously when I convert this into the standard normal, okay, my goodness, sorry. Let me try to replicate this. Okay, when I convert this to the standard normal, okay, my highest point is 0. Where would my 31.5 be? Obviously, it will be somewhere on the left side lah. So less than 0, sir, -1. The answer is negative. Answer is -1, right? Yeah, -1. Okay, so first thing, don't be afraid if your Z score is negative. It is totally fine, because as I said before, the mean now is 0. Okay, we have converted the mean, the original mean, into a standardized mean, which is 0. And so because of that, any number that is less than the mean will become a negative Z score. Totally no problem. Okay, can one, totally no problem. And obviously, any number that is bigger than the mean will have a positive Z score lah. Okay, ini adalah logical. Okay, so when we answer normal distribution questions, I want you to have the picture of the bell curve in mind. Be aware, kamu mesti sedar tau, you have to be aware of where the mean is. And then jangan terkejut kalau kamu punya Z score adalah negatif. Terus kamu, macam tu. Okay, then you become like very annoying lah. Okay, that is the number 1 thing. Okay, you can finish up the entire question B if you want. Okay, but what I want you to do after that is, okay, let's take a look at question C. I'm going to show you the example. Sorry, I don't know why I put the book under my leg. Okay, I'm going to show you the 3 examples and how to use Desmos to find the answer first. Okay, today I'm going to teach you how to find the answer using Desmos. And then after that, I'm going to teach you how to find the answer using the conventional method lah. Okay, which is not using the calculator. Okay, adalah itu guna jadual yang sangat menyusahkan itu, but we have to learn that because that is the conventional method. Okay, so take a look at page 70. Okay, take a look at page 70. I'm going to discuss these 3 examples. I hope I have enough time to do this. Okay, so how to use Desmos for this? Okay, today is change sharing screen day. Banyak betul share screen ni kan? Okay, so when we use Desmos, okay, obviously we have normal this lah. Okay, normal distribution. The first thing you do is you put in, okay, you put in the normal distribution 20. The first one is 20 and then, is it 4? The first example. Is it 4 or 5? Oh, it's 4. Oh no, the standard deviation is 2, kan? Standard deviation, guys, not variance. Standard deviation. Can? Okay? Okay, so standard deviation is 2, the mean is 20. Okay, the question say what? The probability of x is less than 19. Okay, so you click on find the cumulative probability. Less than 19 means negative infinity until 19. Okay, hold on lah. Look at the answer, 0.30853753876, which is the exact same answer in this one. Kan? Okay, then what I want you to do is This is the normal one. Okay, so let's take a look. Since my mean is 20, is over here lah. Okay, look. My mean is 20. Do you notice that the area which I'm shading now is not shown in the this one? Okay, but this is what this means. The probability of less than 19. Sini 19. Kan? Sini 19. And the probability is the entire area that is sebelum nombor 19. That's why this area is 0.3085 yada 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 yada. Okay? But I also want you to do this under the normal circumstances. Okay? If it is the normal circumstances, what is the 19? Okay, what is the 19? Okay, let me change this back to 0 and 1. We know that standard normal distribution is 0 and 1. Sekarang kita punya 19, if we convert it into the x-score, what do we get? If you take a look at the example says the z-score is negative 0.5, negative 0.5 over here. Okay, so do you see? Okay, let me do the normal and the not so normal one. This is normal. This 20 and 2 bahkan. Okay, so this one is negative until 19. Okay, take a look at the two probabilities. They are exactly the same. And 0.30. Sebab mewakili graph. Tapi this first one, green color, okay, sudah kena standardize. Manakala the black color, astaga jauhnya, okay, this is the actual one lah. Okay, 19 and less, okay, it is still the same probability. Tapi ini adalah dengan menggunakan mean 20. Kita kena belajar, we have to learn how to use the standardized one because it's so much easier. Because if you want to do 20, okay, boleh lah kalau kamu mau buat 20. Take a look at the next example. What is the mean? 45. So don't tell me what you want to, astaga, you want to do normal this. 45, the standard deviation is 3. Okay, and then you want to, okay, then lepas tu kamu cari the purple graph. Mana itu purple graph? 45. Nina. Okay, so this is the graph. So it becomes very mahuan, you know. Sorry, it becomes very menyusahkan kalau kamu punya mean sentiasa berubah. Okay, so that's why we have a standard normal distribution where we convert the mean, okay, to 0 so that whatever number that we want to find, this 19 in example 1, 19 when we convert it into the standard normal number, it becomes negative 0.5. And we find that the probability is exactly the same. Okay, we find that the probability is exactly the same. Ini adalah dalam keadaan kita guna mean 20, ini adalah dalam keadaan kita guna mean kosong. So, look at the next question now, 45 and 3. Then dia minta supaya more than 47. Look at the second example. Second example, find the cumulative frequency more than 47. More than 47 means paling sikit adalah 47 sampai infinity. Okay, so take a look at this answer, 0.25249. Okay, and take a look at the answer in the book, 0.2523. Okay, about the same, about lah. Okay, there's going to be a little bit of difference. Don't worry about this. Okay, but today I want you to learn how to use Desmos to find the probability. Okay, if we convert it into the normal this one, so we find that ini 47, kalau kita tukar pergi z-score, 47 akan jadi berapa? Akan jadi 2/3. Okay, so 2/3. Okay, maximum is infinity. So leave it blank. Okay, so you find that the answer is exactly the same. Take a 0.25249, 0.25249. Ini adalah dengan menggunakan graph warna purple yang nun jauh di sana. Now, take a look over here. It's so far away. Okay, we convert everything to standard. Okay, so that we can find the exact same probability. Last example, the distribution now is 63. Okay, the mean is 63 and the standard deviation is square root of 5. Astaga. Okay, if you want to do square root of 5, you do this, square root of 5, like that. Okay? So take a look at this. Under these circumstances, okay, 63, where is 63? Nina. Okay, so far away. So instead of making your life difficult, okay, instead of making your life difficult, we change it back to the Z score. Tengok apa X yang dia mau kita cari. Dia mau cari X 60 sampai 65 bahkan. Okay, so we put 60 sini, 65. The answer is 0.7245, which is the exact same answer in your workbook. Tapi ini adalah dengan menggunakan the non-standard normal distribution. Kalau kita mau standard, 60 ini kita tukar pergi score Z, which you will get negative 3 over square root 5. Oh no. This is so menyusahkan. Okay, sorry ya. Negative 3 over square root 5. So, negative 3 over square root of 5. Okay, begitu. Until 2 over square root 5. 2 over square root of 5. Begini. Look at the answer. Exact same. Okay, exactly the same. 0.7245, 0.7, begini. Okay, so your task today lah, okay, I want you to play around with this Desmos, okay, and I want you to see that actually we can use both ways. Betul, dengan menggunakan teknologi seperti begini, we can use both ways, okay, except that kalau kita mau menggunakan the non-standard normal distribution yang bukan standard, okay, masalahnya adalah kita punya graph, our graph will always be changing place, and that's a very big problem. Yes, Eldon.
Kalau anda faham macam mana tu, sir?
Apa yang kau tidak faham? Okay. What do you
yang you're explaining now.
Okay, which part do you not understand?
The part yang the min and the max. The answer lah basically. How kenapa
Okay.
sama gitu.
Okay, kenapa salah?
Kenapa sama?
Okay, sebab this one is if I use the mean 63 and my standard deviation is square root of 5. The problem with this graph is the graph of, okay, this is purple color. So the purple color graph, the graph is so far away, it's like over here. Okay, and this 60 sampai 65 bahkan sudah diberi dalam soalan lah. If you take a look at the example, they are asking you to count the probability between 60 and 65, which is over here and over here. Is that okay so far? Do you understand so far?
Yes.
Okay. So the problem arises where if your mean changes, then your graph also will change place, So it becomes very susah for us. Means every time we want to find a probability, we have to draw a different graph. And that makes a lot of problem for us. What if ini baru 60 tau? What if your mean is 600? You have to move your graph down all the way to 600. So we don't want that lah. So in order to solve this problem, some brilliant mathematician what he did was he converted these two numbers. He used a formula to convert these two numbers to make it a standard normal distribution. Standard maksudnya apa-apa kamu punya mean dan apa-apa kamu punya standard deviation boleh di-convert kepada standard deviation, and when you want to find the area between 60 to 65 under the same formula you will find the same area, which is the same probability. So this conversion is actually very important to us because it makes our life that much easier. Otherwise, setiap kali kamu mau mean yang berlainan kamu kena cari. Do you know? Okay, sorry Do you know how they used to find this area without the standard normal distribution? Do you know? Can anybody take a guess? Anybody want to guess? Sorry?
Table.
No lah.
Jadi apa?
Ini mesti orang yang ambil tuition ni No. Think about it. How did they find this area? We have learned this already, people. Think about it. How did they find this area?
Differentiation.
Integration.
Integration. Okay. So Apa differentiation ni? So in the past, before this brilliant mathematician found a way to convert all mean and all standard deviation into a standard normal, everybody had to find the area in order to count the probability. And then they have to they have to integrate this in order to count the probability. Sangat menyusahkan. Okay, so because of that, some brilliant mathematician, what he did was, he said, okay, let's find a formula, okay, that can convert all sorts of normal distributions into a standard one. Sebab kita dapati bahawa in the normal, dalam keadaan normal kan, the area under the graph is 0.724597 blah blah blah. Tetapi selepas conversion, when we convert to a standard one, we find that the area is actually the same. So kenapa kita mau susah-susah untuk membuat integration? Kan bagus kita belajar, okay, we convert all these numbers into standard numbers so that we can just key in the numbers here and we will get the exact same probability. Okay, of course, yes, I know keying in the numbers is because of Desmos lah. Nanti next week I will teach you how you're going to calculate actually lah. How you're going to determine, macam Eva cakap tadi, how you're going to determine from the table. Okay, actually your calculator can also help you, but your calculator can only understand standard normal distribution. Okay, kalau kau punya mean besar-besar dia tak boleh tu. Okay, so that's why we have to learn how to convert all these two numbers lah. Okay, this 60 dan 65 kita tukar pergi standard, okay, supaya kita dapati bahawa the area is actually the same as when we would do in a normal in a standard in a kalau kita plot graph yang biasa-biasa lah. Okay, and that's why we do this. Sorry, I don't know if I'm answering Eldon's question or even if you understand, or am I going, maybe I'm going too fast.
Faham.
Oh, okay. All right. So the formula that I showed you just now, Z equals to X minus mean over standard deviation, is how you convert 60 menjadi negative 3 over square root 5. Take a look at your example in the textbook that is there. How you convert 65. 65 minus the mean is 63. Okay. Then the whole thing you divide by, okay, the whole thing you divide by square root of 5. Okay, take a look, 0.894, which is the same as this, 2 over square root 5, 2 over square root of 5, 0.894. Okay, begini. So we want to convert this 65 untuk menjadi this one, 0, yeah, okay, fine, I can use this lah. 0.894427191. Okay, you find that the answer is still exactly the same. Okay, so the two important kemahiran yang saya mau kamu pelajari pada hari ini, and I'm keeping this as I'm doing this very slowly lah. Those of you who took tuition, it's like, when is sir going to get to the table? Okay, the reason why I don't go to the table is because I want you to understand how this graph didapati. Kenapa yang warna hijau ini begini? Because okay, this is 0.89 这样子 and over here is negative sorry 60. Okay, 60 negative 1.3. Okay, negative 1.34160785. Okay, something like that lah. So here is 1.3, here is 0.89 sebelah kanan, here is negative 1.3. Okay, so when you key this in here, we find that, oh, luas antara yang sini sampai sini, ini yang warna hijau ini semua adalah 0.724591, which means that the probability of getting the number between 60 to 65 is this one, 0.7245, yada 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 yada. Cuma kita kena pakai cara standard. We have to convert any distribution to a standard normal distribution. Okay, why do we have to convert it to standard normal distribution? Hadirlah pada kelas hari Isnin dan saya akan jelaskan kenapa. Today, your main task is to finish page 70. There are only 6 questions in page 70, but I want you to explore this Desmos part. Okay, explore the Desmos and take a look at what happens when you change this number. Okay, as much as you can, try not to totally depend on the answer book. Take a look at this answer which is given to you. Terus kau catat di sana. Okay, learn how to convert normal number into standard normal number by using the z equals to blah blah blah. And number 2, key in. This is from the question, kan? And this is from selepas kamu convert. Compare the 2 answers. Is it the same or not? Okay, and thirdly, I want you to look and see how they draw the area which represents the probability. Okay, I feel that I sangat membebel hari ini, but I'm going to repeat it one more time lah, okay? Sebab saya sangat suka repeat dan saya sangat suka membebel. First thing is page 70. There are only 6 questions there. Okay, I want you to explore all 6 questions by using this Desmos. Key in the numbers that are given in the question di sini. This is the mean, this is the standard deviation. Okay, and then key in the numbers. Dapatkan dia punya kebarangkalian. And then convert this 60 and 65 to the standard normal numbers dengan menggunakan Z sama dengan yada yada yada. Okay, next is this one. And then compare these 2 answers. If both your answers are the same, means your probability is correct sudah. Okay, of course must be the same as the book lah. Okay, but I want you to explore this because this and this are connected. So when you open your Desmos later, your standard one, ini mesti kena tulis lah, normal this bracket 0 dash comma 1. Yang tidak standard ini, normal this and then bracket, different question will have different mean, different question will have different standard deviation. Contohnya soalan nombor 1, the mean is 32. The standard deviation is 2.5. So over here you click 32, this one will be 2.5. Okay, tapi yang standard ini adalah 0, 1, ini jangan ubah. Okay, then here dia cakap apa? Less than 28.25. Less than 28.25 means dari negative infinity sampai 28.25. Paling besar 28.25 kan? Yeah. Okay, so let's take a look at this graph, purple color. Okay. Saya habis masa sudah. Sorry. I need to go. Okay, so mean is 32. Okay, you see mean is 32, but 28.25 在这里. 28.25 is here, less than 28.25. Okay, take a look at the answer. 0.066807, blah, 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 blah. Okay, then convert. Okay, convert this 28.25 to become the Z score. Okay, when you convert, you will get the answer negative 1.5. Okay, and over here must be infinity lah sebab di sini infinity kan. Okay, so kita kekalkan ini infinity. Take a look at this answer. It is exactly the same. Not standard, standard. Okay. So do this for all 6 questions and of course fill in this one. And then kalau kamu rasa kamu masih mau main dengan Desmos lagi, mana tahulah kan di hujung minggu kamu ada banyak betul masa kamu mau ini. What you can do is you can take a look at you can take a look at example 18. Okay, take a look at example 18 in your textbook, page 174. Okay, to see look at the example lah. Okay, look at the example, but play around with Desmos.